Hello, everyone, and welcome to the Fundamentals of Air-Breathing Propulsion Engines course. My name is Raul Otero Jr., and I'm excited to have you here today. We're going to be talking about some very interesting concepts throughout this course, and I just wanted to provide a little bit of an introduction to this course before we got started with uh, the important stuff, what you really want to know from this course. So first, I'll talk about myself just so you have an idea of who I am and you can actually see a picture associated with the face, or sorry, with the sound. My name is Raul Otero Jr., as I said, and I was born in Havana, Cuba. And I came to the U.S. Really early in my life, and I've lived here ever since. Um, I attended Virginia Tech as a mechanical engineering student, and I got my bachelor's degree there as well as my PhD degree. And note that I don't have a master's. That's because Virginia Tech offers a direct PhD program, and I took advantage of that. Um, in terms of my background and experience, I've previously worked with Rolls-Royce, Pratt& and Whitney, Honeywell, and Honeywell Aerospace, which are some of the biggest gas turbine engine manufacturers in the United States. Um, so I've worked with them as an intern for a couple of them, and actually Rolls-Royce sponsored my PhD research, so I was very thankful to them. A little bit about that research: I basically developed a thrust sensor that uses acoustic measurements to measure thrust non-uniformly or non-intrusively. Sorry, and it could measure the non-uniformities in the flow field, and it's still an ongoing research topic and work, but I was primarily associated with that, and that kind of instilled in me a desire to teach people about the gas turbine engine industry and air breathing engines and that kind of stuff. So in terms of my general interests, I'm interested in the advancement of aircraft propulsion systems. I'm interested in air acoustics. I meant to list more information there, but some of my hobbies include I like working on web development. I like coding and learning how to code different languages. Right now, I'm on a Python kick, so I'm trying to learn how Python works, which it gets a lot easier when you learn one language. You can transfer that knowledge to other languages. But so I'm going to be using some of that stuff that I learned to kind of create some really cool things for you guys to use throughout this course. So finally, I wanted to just point you guys to our website. The website is engineertomorrow.org, and that's where I'm going to be putting all of this content as well as additional information that you guys can obtain throughout this course. And I'll just reference that website or provide a link, and you guys can just click there and go check out the site, get whatever you need, and move on with the course. Okay. So the reason I'm creating this course is because I want to get other people interested in the subject. It's very interesting to me, and if you made it here, I think it's interesting to you too. So I want to make it as easy for you to understand some things which may not have been explained right to you, or you just haven't had the access to that information. Okay, so next I wanted to talk about some course objectives, just to kind of tell you what I'm expecting to provide you with. So the first objective will be to identify and describe the major components of air-breathing propulsion engines. So we'll talk about the inlets, the nozzles, the compressor, the combustor, the turbine, and different designs, and how those can all be put together to create an engine that will move you through the air. And there are different types of engines. So you can look at a ramjet or a turbofan engine or a turbojet or a turboprop. So we'll be discussing why you would use one over the other one and outlining some cycle information about it so that you can maximize the performance of an engine. So um, along those lines, I want to outline some really important design considerations, which are based on mathematics. So we'll do some sort of analysis using math to describe certain behavior and why you would choose something over something else, and then also look at some historical context. So in the past, there have been a lot of experiments and a lot of empirical data that is often used in the field in order to make decisions. So I will be pointing you to certain historical experiments, and you can make informed decisions about your design based on that. Number three, so I told you guys I like to program and learn how to program. I'm a big dork. So one of the things I want to do is help develop some useful tools for engineering students and industry professionals so that they can use them during their daily work. So on the site engineertomorrow.org, I'm going to try to create little pages that have certain calculators or certain animations that you guys can use either to explain it to your colleagues or just you need to run some quick analysis and figure out how things work. So and those will probably have some information on those sites just explaining how it works and that kind of stuff. And then my final objective is just to help prepare students for a potential career in the aviation propulsion industry. So I'm going to do my best to cover subjects throughout this course, but there's a lot of information that you may need from outside courses, such as a preliminary course in thermodynamics or aerodynamics or something like that. So I'm going to try to point you in the right direction, but if you do have any questions, feel free to try to contact me. Depending on where you're receiving this information, you may have a different way to contact me, but you can probably get to me through the website down at the bottom. So I just wanted to point out that that this is an advanced engineering subject, so you may want to consult some other texts for information about other topics that we describe. So next, I'll talk about the course outline. So let me just back up real quick. So this course is going to be an ongoing development. So I'm going to start with certain topics which are very broad, and then as I go, I'm going to create videos about these topics and kind of try to provide more detailed information. So initially, it may have certain content, but I'm going to try to continue to build on this just in time when I have a chance. And that'll just provide more of a benefit to you and more access to information for you. And I'm going to try to do that as time allows me, basically. So in terms of the outline, I'm going to talk about first the aerothermodynamics of air-breathing engines. So briefly discuss efficiencies, cycles, the types of engines, why you may want to choose one engine over the other. And this will just be a brief introduction to air-breathing engines. So next, I'll talk about, I'm going to say perhaps one of the simpler topics in these engines, but they're still pretty advanced. There's aerodynamics involved in different geometry, but I'll talk about the inlets and the nozzles and how you can design those for subsonic and supersonic flows. Next, I'll go into the compressors. So the compressor is what raises the pressure of the air going into your system. So I'll be describing different compressor designs. There's two types of compressors. So the first one I'll talk about is the axial compressor, and later I'll talk about centrifugal compressors, and it's just different designs for different conditions. Later I'll talk about combustors. A lot of times people think that this is black magic. It's because it's an ongoing research field and there's a lot yet to be learned about combustors, but I'll do my best to address some of the important combustor topics and point you in the right direction if you're interested in more information. Next, I'll talk about the turbine. So the turbine is what allows the compressor to turn. So you start extracting some work from the air or extracting energy from the air going out of the combustor in order to power your compressor. And then some of the air you have to allow to get through, and that's how you create the propulsion. So I'll be describing the types of turbines and blade designs that you can use to extract some of that work or energy from the air. And then finally, I just put down this little section called additional information, and I intentionally want it to be an open-ended section. So in this section, in the future, if somebody's interested in the materials or the fuel considerations for air-breathing engines, I might add something to this section to address that, curiosity of somebody, or just maybe I just want to add more information so that you have access to it. So, and this could include gears, bearings, like I said, fuels, materials for turbines. because they're in the hot section, or maybe something about aeroacoustics because I worked with acoustic measurements in air breathing engine environment, so that's something interested to me. So I would provide that sort of information here. Okay, and then kind of to wrap up this introductory video, I just wanted to provide a quick course recommendation. So first and foremost, I'm gonna do my best to make this course as self-sustained as possible. So what I mean by that is you don't have to buy anything else or you know buy access to information another way of something that I am providing for you. This is something that I provide for you. So however, I do want to strongly recommend that you get 2 books if you are really interested in this field. So the first one is called Mechanics and Thermodynamics of Propulsion. And this is by Philip Hill and Carl Peterson. Okay, and it's about $120 on Amazon, which could be a lot for some people, but it's basically the Bible of this field. So it just provides so much general information and points you in the right direction to different topics. So I really highly recommend that you get this book if you are interested in this field. And obviously, there's other books that may help you as well, but this is the one that I used during my graduate studies to learn about this topic, and it was very insightful. The questions at the back of the chapters are sometimes pretty hard, but I mean, if you're working on this with a friend, you may be able to actually figure those out and get those done. And then the other one that I wanted to point you to is the Gas Turbine Engineering Handbook by Marwan Boyce. And you could find it for $99 on Amazon. This is what I saw when I went on Amazon today. And this, like it says, is a handbook. So they just have so much information in this book. And the way the book is set up, it's not necessarily for just air breathing propulsion engines. It's just air breathing engines in general. But a lot of those concepts that he describes apply to the air breathing field or air breathing propulsion field as well. So it has a lot of great information. It talks about maintenance, testing procedures. It has so much information on it that it's worth the investment if you are more advanced in this subject. So with that, I'm going to wrap up this video, and we'll go ahead and get started. And thanks a lot again for coming to this course, and I hope you stick around. And I'm always looking for help improving this course, even though I'm just getting started. But if you want to help me out in any way, maybe some feedback, I would really appreciate that. So thanks a lot, and I'll see you guys in the next video.